Hello and welcome to iOS 9 iPhone and iPad app development, Lesson 1, Swift 2.0 Programming Basics. By the end of this lesson, you'll be able to create a playground in Xcode. You'll understand the basic Swift syntax. You'll be able to create variables and constants. You'll be able to understand and use 3 number types in Swift. And you'll be able to create a rich text playground. Okay, in this video we're going to be talking about the Swift 2 programming basics, so specifically the Swift syntax with constants, variables, and comments. And at this point you should have already downloaded Xcode from the App Store. If you haven't, please pause the video and go do that now, because we'll need Xcode to continue. But right now it's time for your Tech Info Bite. These are little info snippets before we begin a lesson, especially while we're learning Swift. And this is on Swift constants, variables, and comments. Constants and variables are properties that store values of any type. A constant is best used when the value is not expected to change. A variable is best used when the value is expected to change later in the program. It's important to keep in mind that once declared, the value type of a constant or variable cannot be changed. Comments are for humans to read and generally explain what's happening within the code, and comments should be used sparingly, only when it's not clear what's happening. So let's jump into a playground and look at these in depth. So when you first open Xcode, you're presented with this screen, and from here there's a few places you could go. You could get started with the playground, which is what we're going to do in a second. You could create a new project, which is when you're creating an application. You could check out an existing project from a repository. This populates recent projects over here once you've created a couple, or you could use this button here to open another project entirely. Now, if this isn't showing, you can do the same thing from the File menu. Just click File, New, and Playground. That's what we're going to do. Essentially by clicking this here, and I'm just going to move this into place, and we're going to name this playground Intro, and you should have already a folder to store these playgrounds in. So I'm going to click Next, and I have a folder here called Playgrounds that I'm going to keep it in. So I'm just going to click Create, and that's going to create our playground for us. So the first thing you notice about the playground is it's divided into 2 sections, left and right. And the right side is basically what the code compiler has worked out for you. And the left side is where you put all your code. So I'm just going to make this a little bit bigger here. And on the left hand side, if we look at this here real quick, we'll see that they're starting off with a comment, because comments start off with 2 forward slashes. Now the fact that this has a colon after it means that this is a rich text comment, and we'll get into that in a couple of videos. But basically everything after those 2 slashes on that line will not be evaluated by the compiler. That is for a human to read only. Now this line 3, import UI kit, is importing a framework that we don't really need right now, but I'm just going to leave it there. And on line 5, we're creating a variable called str, and we're assigning it the value of hello playground, which is a string, and you can tell it's a string because it's in between 2 quotes. So you may already have a couple questions about this, and the first question might be, where are my line numbers? Because line numbers I don't believe are by default activated. So if you go to Xcode and then Preferences, and you go to Text Editing, it's the first section that says line numbers. Just make sure that's selected. Another question you might have is, your theme looks different than mine. That's okay. You can use whatever theme you'd like. I'm just using this theme so that it's easily read, but you could select any of the other themes if you'd like. I'm just going to stick with presentation for right now, and I'm just going to close the preferences pane for the moment. So getting back to the code, whenever you see double quotes, you know that you're dealing with a string, and a string is nothing more than a bunch of characters in between double quotes. So basically a paragraph or a sentence or a word. So what we're doing here is we're saying var, which is a keyword, which means you're about to declare a variable, and then we name the keyword, we name the variable. In this case it's str, and then the equal sign is an assignment operator. So then after we set the assignment operator, we go ahead and we put our string in, and that is a bona fide string. So if we wanted to create another string as a variable, then we would say var, we name it. In this case I'm going to say name and set it equal to my name. Now my right hand side has scrunched up, so I'll just open that a little bit. You'll see that what it does is it evaluates what the variable actually is, and it prints that out to the right hand side of it. Now a couple things you may be wondering is that I'm not actually saying that this is a string, and if I were to say that this is a string, it would look something like this. We would put our semicolon in, and then we would say string equals. But since it's brutally obvious that it's a string, the compiler will actually infer that this is a string. Then it's actually poor form to have the type declaration there. So we would just keep that out because it's brutally obvious that that's a string, and it's brutally obvious that the one above it's a string. So if I go on to another line, I create a variable called number1, and I set that equal to 1, which is an integer, and an integer is nothing more than a whole number, negative or positive. Then this will be inferred as an integer. There's no need for me to put a type declaration on that either. Okay, so now a couple things to keep in mind is that now that I've declared str a string by setting it equal to a string, I can't come down here later and say that str equals 6, because that's now an integer. That's going to give me an error because I can't assign a value to something that already has a type with a different type. Okay, so once str has been assigned as a string, it must always remain a string, and the same thing go for name and number1 here. Okay, so I'm just going to erase this. I'm not sure why it didn't give me an error. There's my error. Okay, so you may also be wondering where the semicolons are, because in a lot of languages the line ends with a semicolon, and in fact I could put a semicolon at the end of each of these lines and it would still work. However, since you don't need it, and the compiler detects the end of line character when you hit return or when a line ends, then why bother using it? So you save yourself a keystroke. It's basically a period at the end of a sentence, but now you're just using return. Okay. Also, what comes to mind is, does white space matter? And if we move this over and I put a ton of white space in there, you'll see that it has no difference on the compiler on the right hand side. So this is not like Python where we use a hierarchy or anything. This is just white space does not matter, except for one case, and that's when we're using this assignment operator here, the equal sign. So if we have a space on the front of it, we need to have a space on the back of it, or we need to have no space at all. However, you'll see that that's quite unreadable, so it's recommended that you use a space, the assignment operator, and then your value. Okay, so white space does not matter. Semicolons are not needed. As you see, Swift is becoming a very easy language to learn. So as you see, the variable name has been declared, and I've assigned it the value of Jason Ribka. But if I wanted to change that now later in the code, I would just say name equals, and I would reset this to whatever I wanted to say. So let's say I just want to go by Jason instead of Jason Ribka, then I just go ahead and assign that to Jason. Now in reality, if I'm assigning a name to something, I should probably use the let keyword, which makes it a constant instead of a variable, which means it can't be changed. So if I make a variable or a constant called my name, and I set that equal to Jason, then later in the code, I can't say my name equals Tom because I've declared it as a constant, so it must always remain the same value that I originally set it to, which was Jason. Now, there is a slight performance enhancement when using the let keyword over the var keyword, because Swift uses something called automated reference counting, and it basically knows that once it's assigned Jason, it doesn't need to worry about changing that later in the code, so it doesn't need to allocate any memory for it. Now, also because of this, you don't need to worry about garbage collection or anything like that. You don't need to go cleaning up after your variables and disintegrating them or anything. They just are there when needed, and when they're not, they're destroyed, basically, by the compiler. Now, in a playground, the compiler is running over and over and over. This way it constantly evaluates what's going on. So it's a little, doesn't really matter in a playground. But in your program, always try to use the let keyword, which then creates a constant whenever you can. Okay? So if you have something that's not expected to change, use let. And if you have something that may change, use var. Okay? Another thing I want to point out about declaring variables and constants is the naming convention. So if you look, when I declared my name, I started out with lowercase letters, and for the second word I used an uppercase letter to start it, and then lowercase letters. So that is the proper naming convention. That's called camel case, and basically it means if I made a variable called my dog name, it would look like this, my, and then I would capitalize the D and the N, and I would just set that to whatever value it's supposed to be. And also, another thing to keep in mind when you're naming variables is to name them something that makes sense to what the value is going to be. So I wouldn't say my dog name and then put my dog's age in there. It should be very clear that my dog name is going to be a string, and it's going to be, you know, whatever the value is, obviously. In this case, it's going to be Mikey. Okay? So keep that in mind, your strings, and whenever you're naming your variables, to try to make them always use camel case. That's the proper form. And the variable name should clearly reflect what the value is going to be. Now, I want to introduce you to something. This is called string interpolation. So if I say var another string, so clearly I'm going to be making a string here, and I set that equal to an empty string, what I can do is I can pull variables into here, and the syntax we use for that is the backslash and then parentheses, and then within here I can pull out whatever variable I need, like my name, and then I would say and then I would put another set of those parentheses in, and I would say my dog name. And you'll see on the right hand side what that does is that sets the value of another string to be the value of my name, the string and my dog name. It's also worth noting that this also turns the value into a string as it does that, and I'll show you how that works, because if I say var the number and I set that equal to a string and I put the number 1 variable in here, then you'll see that that comes up in the compiler on the right hand side as a string version of the number 1. And the last thing I want to touch on in this video are comments. Comments have two purposes. Number one, they can comment out code that you don't want to run. So if I didn't want to reassign this, I could just put 2 forward slashes in front of it, and that'll comment it out, and you'll see the compiler no longer evaluates it. Now, there's also a quick way to do this. If you have multiple lines and you just want to quickly comment them out to test something out, if you highlight them and press Command question, it will comment them out that way, and command question will uncomment that as well. Now you can also use a multi-line comment that starts with a / and an asterisk, and you'll see that that comments out everything. But let's say I only wanted to comment out to here, I'll put an asterisk and then a / and then everything else is recompiled again. Okay, now I'm getting an error because I commented out numbers, so I'm going to take these comment sections out. But comments should only be used to comment out code and to leave important notes to yourself or someone else who's going to view your code so they can understand it better. We're going to get much more into comments in a later video where we talk about rich text comments and things like that. And for right now, I think we're done. What you should do before you move on is play around creating a couple variables, put a couple variables together to create another variable, and just kind of get your head wrapped around the syntax a little bit. And then we'll move on to the next video where we talk about numbers a little more in depth. We're going to continue our discussion on Swift 2 programming basics, this time turning our attention to number types, type safety, and type conversion. So as you guessed it, it's time for the Tech Info Bite on number types, type safety, and type conversion. There are 3 number types in Swift. You have integers, doubles, and floats. Integers are any whole number, negative or positive. Doubles are a decimal value number accurate to 16 decimal places. Floats are a decimal value number accurate to 6 or 7 decimal places. It's also important to realize that floats were developed for 32-bit systems, while doubles were developed for 64-bit systems. Keep in mind that doubles are the default inferred decimal number type. Therefore, you must declare a type when creating a float value. Type safety and type strict both mean that once a value has been assigned a value type, it cannot be changed. Type conversion is the process by which a value is converted from one type to another, and we'll look at all these concepts in a little more detail in the playground here. So since we're talking about numbers, I've gone ahead and created a playground, and I just called it numbers, and you should do the same. So when we're talking about Swift code like this, and we start a new topic like numbers here, what we're going to do is just create a new playground each time. This way we can refer to that particular topic if we need to. And also all the playgrounds that I create are going to be available in the source code download, so you can access those at any time as well. So since we're talking about numbers, it would make sense to create a few of them. So we'll create a variable called a, and we'll set that equal to 3. And I'm just going to put a comment here that this is inferred as an integer. Okay. We're going to make a variable b, and we're going to set that equal to 12.1. And this is also going to be inferred by the compiler, but this time as a double. And then we're going to create a variable called c, and we're going to make that 12.3. But we're going to declare the type back here as a float. This way, we know that this is a float instead of a double. So what is the big difference between a float and a double? Well, a float is accurate to about 6 decimal places, where a double is accurate to about 16 decimal places. So why do we even use floats? Might be a question that comes up. And the answer is that we've developed so many things that deal with floats that we're still referring to floats, so we still need to kind of keep those in our programming logic at the moment. Now you can convert a float to a double and vice versa so that you can interact with them, because as you'll see, if we try to do mathematics on these and I try to add a and b, so if I say variable d is equal to a plus b, then you'll see that I actually will get an error here because I can't add an integer to a double. What I need to do is I need to cast one of these as the other. So what I'll do is I'll say I want to take the double version of A, which I do by just saying double and encapsulating it, and then I want to add that to B, and that will get me the result that I want, and that will be a double as a value type. So it may be useful to you to actually see the difference between a float and a double. So we'll create a variable here called double value, and we're going to set that equal to 12.2 divided by 3.1, and you'll see the result pop up on the right, and you'll see how many digits there are after the decimal place. But if I make a float value, and I say that that's going to be a float, and I set that equal to the same thing, 12.2 divided by 3.1, then you'll see the difference in the accuracy on the right hand side, where a float value only goes 1, 2, 3, 4, 5, 6 decimal places, where double value goes many more. Another thing to keep in mind when we're dealing with numbers is that if we go ahead and create a variable, and we'll just say this is sum, and we set that equal to 5 plus 3 times 4, then you'll notice that the result is 17. But keep in mind that during regular mathematics, 3 times 4 would occur first, and then it would add the 5. So if we actually wanted to do 5 plus 3 and then multiply by 4, we would encapsulate this, and it would change our result from 17 to 32, because now we're taking 5 plus 3, which is 8, and then multiplying it by 4. So it does matter the order in which you do things, and if you follow the standard mathematic rules, division and multiplication take place first, then addition and subtraction. Unless they are encapsulated in parentheses, then that takes place first, and then the rest of the calculation will take place. Another thing that you'll find kind of interesting is if we take two integers, so I'm going to create two of them, and I'm going to make one equal 6, and then I'll make y equal 9. If we go ahead and we perform some mathematics on these, and I'm just going to change this to a 10, so it's not a very even mathematical number. So if we do some mathematics on these, you'll see that if I say, if I set a variable, and I say that that's z, and that equals x divided by y, you'll notice that I get 0, where you might be expecting that I would get some other type of number. But let me change this around so it actually gives us a result. So if we do y divided by x, then it goes in one time. And that's because 6 can literally only go into 10 one time. If we want to get the remainder, we need to create a different variable. So I'm just going to create a remainder r, and then we would say y modulo, which is the percent symbol, x, and that'll give us the remainder. So really you can see that y goes into x z times, which is 1, with the r left over, which is 4. So that's basically your remainder operator. So as you know, type safety or type strict means that once you set a variable, it can only be that same type. So in other words, we set x to 6, which is an integer, which means that x must always be an integer, and y we set to an integer, which means y must always be an integer. That's type safety and type strict. Type conversion, however, is when we need to use it as a different type of value. So if we wanted z to have a more specific result, we could cast both y and x as doubles by saying double and encapsulating it. Now you'll notice I get an error until I do the other one, because I can't go ahead and take a double and divide it with an integer. That's just going to give me an error, so I need to cast this as a double also. And so when I do that, you'll see that I get a double as a result on the right hand side, so that's the more accurate result. Okay, so we're going to leave it here at numbers. I suggest you play around with numbers, typecasting them a little bit. You know, seeing that they only interact with one another if they're the same type, looking at the difference in values, so on and so forth. So go ahead and do that, and then move on to the next video, and I'll see you there. This video we're going to talk about rich text playgrounds. So we're going to jump right into our tech info bite. Rich text playgrounds are Xcode playgrounds with formatting markup in certain areas. Rich text playgrounds are perfect for teaching, explaining code, and presentations, but in practice, rich text playgrounds are not used all that often. With that said, let's go take a look at how to create one and what one actually looks like. So this is an example of a rich text playground in Xcode, and basically this kind of reads like a tutorial. I wrote it that way, for your benefit. Now, this is included in the source code. It is called richtext.playground. And the way we do this is if we hit editor and then show raw markup, then we can see this not formatted. So we can see how to actually do the formatting. So, as I said, this is in your source code files. And I'm not going to go through this, but basically what it is when you say that you're going to do a rich text comment, then basically you can use any type of formatting that is formatted with Markdown. So Markdown is a formatting language, and it's really simple to use, and it allows you to make all sorts of headlines, links. You can even put pictures in your playgrounds, bold text, italics, and basically if you look through this, the regular comments are used to explain what follows throughout the playground. So you can kind of teach yourself Markdown if you go through this playground, and Markdown is what you use to go ahead and mark these up, basically. So I'm not really going to dwell on rich text playgrounds because this is something you can kind of do on your own. Just look at it in the code view, editor, show raw markup, and you'll see exactly what I say about each section and then how to actually format that. So go ahead and do that. I'm going to switch this back over to rendered markup, so when you open it up it'll be rendered. And if you have any questions on rich text playgrounds, post them in the forums and we'll get them answered. Welcome to iOS 9 iPhone and iPad app development, lesson 2, Swift 2.0 control flow. In this lesson we're going to learn about control flow, and by the end of the lesson you'll be able to understand how control flow impacts your code and specifically what control flow is. You'll be able to properly use an if-else statement, a switch statement, and the ternary operator, and you'll understand how loops work. So over the next few videos we're going to cover this in detail, and I'll see you there. Okay, so we're going to be talking about control flow in this section, and control flow is just as it sounds. It's how you control the flow of your code within your program. So we're going to be talking specifically about if-else statements, and that brings us right to our tech info bite on if-else statements. If-else statements are the most common type of control flow in Swift and most other programming languages. If-else statements evaluate a condition. If the result is true, then the code in the first code block runs. Otherwise, the else statement code block is run. If-else statements are not limited to two results. You can use the else-if syntax to make endless possibilities. So let's take a look at if-else statements in a little more detail right now. So we're talking about control flow and specifically the if-else statement. So probably the best way to conquer this would be to go ahead right into an example of how the syntax is. So first I'm going to create a variable, and I'm going to call this the condition, and I'm going to make that a Boolean and set that equal to true or false. Okay, now mind you, I did write that in poor form because as I set it as false, it's clearly a Boolean because a Boolean can only be true or false. So I didn't have to say that that's a Boolean, but I wanted to show you how to declare one anyhow. So moving on to an if-else statement, what we're going to do is we're going to say if the condition is equal to, see the double equal sign there, true. Then we're going to open a code block, and we're going to run some code here. If true, run some code. And then otherwise, and we open another code block, and then if false, run some code. Okay, so basically, if the condition, or the value of the condition is true, then the code in the first code block will run. And when I say code block, I mean from here to here is a code block. Otherwise, this code in here will run. So let's look at a real-world example of this. So I'm going to create a variable called temp, which is going to be the temperature in Fahrenheit. I'm going to set that equal to 32 degrees, so that's going to just be inferred as an integer. I'm going to create another variable called isFreezing, and I'm going to set that equal to false. Actually, I'll set it equal to true since it's 32 at the moment. And what we're going to do is we're going to write an if statement that's going to check the temperature, and depending on if the temperature is 32 or below, it's going to set it to isFreezing, and if it's not, it's going to set it to false isFreezing. So we're going to say if temp is less than or equal to 32, then we're going to set isFreezing equal to true. Otherwise, now note, you don't actually have to have an else statement if you don't want to, but in most cases it makes sense, and in this case it does. We're going to set isFreezing into false. Okay, so now if we mess around with this a little bit and we make this 35, then you'll see that isFreezing down here becomes false, and you can see that because this is highlighted over here in the compiler instead of this, because we didn't do any print line statements or anything to confirm any of this. So what happens with an if-else statement if you need to evaluate more than two conditions? So in other words, we need something more than just true or false. Well, what we'll do is we'll create a variable called the number, and we'll set that equal to 3. And then we're going to write an if statement here. I'm just going to create a little room. And we can say if the number is equal to 2, or we'll say 1, then we'll use the print command, which is you just type in print, and then whatever you want to print in here, you would print. In here we would say the number is, and we'll just pull out what the number is by saying in here the number. Okay, and then in order to evaluate for 2, we would say else if the number is equal to 2, then we can do the same thing. We can print the number is, and then we'll do an else if the number is equal to 3. We'll do the same thing. And then what we can do is just write an else statement to catch any other values. So otherwise, we're just going to do the same thing, print the number is the number. So now this shows you that the number is 3. So automatically through our else if statement, it's evaluating that the number is 3. And I want to point out this / and the n here. All this is a new line character, and this appears in some version of Xcode, some versions, and it doesn't appear in other versions of Xcode. So if you're getting the / n, don't worry about it. In an actual Xcode project, this won't be an issue. It's just an issue right now in some of the playgrounds, depending on what Xcode version you have. So it's just a new line character. Doesn't really mean anything. You can just imagine that's not there. Alright. So if we change this to 1, then you'll see that it says the number is 1. And if we changed it to 111, then our else statement would catch it, and it would say the number is 111. Okay? So now we can also do things, instead of just saying the number is equal to, we can also do other things. So if I add another variable here, and I say is valid, and I set that equal to true, then what we can do is we can use the AND operator. So we could say AND is valid is equal to true. Then nothing will happen if either of those conditions are incorrect. So if I make this false, then you'll see that technically if we were doing anything other than a print line statement, then nothing would happen over here. Okay, nothing would actually happen in your console. And that's because we're using the AND statement. That means this must be true and this must be true. Or we could use the OR operator, which is the double pipes. And the pipe is used by using the shift button and pressing the key above the enter button. So 2 pipes. That means OR. That means whether number 1 is 1 or is valid is true. If either of those is false, then it will print out on the right hand side. Otherwise, it'll skip and do nothing. Actually, ours doesn't skip and do nothing, because no matter what happens, we're going to print the number in this particular coding environment the way we wrote it. It's also worth pointing out that when we're comparing a Boolean, we don't actually need to say if it equals true, if that's what we're looking for. So if we're looking to see if is valid is equal to true, and then run some code, then we don't actually need to put is true here. So we could take this out, because automatically we know that we're checking to see if is valid is true. And if it is, then we're going to run some code, and otherwise we're going to do something else here. Okay, so basically that's just with Booleans, but you can write it out the long way if you'd like. So if you're checking to see if it's false or if it's not true, and you say is not by saying exclamation point equals. So if is valid is not true, that's the same as saying if is valid is false, obviously. Then you run the first section of code. Otherwise, you run the second section of code. And really, that's it on if-else statements. You will be using if-else statements a lot in your programming. One thing you'll be doing is something like checking for an error. So we'll create a variable called error, and we'll make that an NS error. Oh, I can't do that because I don't have a framework in here. But if we make an error, and we just set that to true, then one thing that you will be doing quite a bit is you'll check for an error to have a value. So you would say if error is not equal nil, and then you run your code, and otherwise, generally, you would go ahead and print your error. And it's giving me an error because error is a reserved word, I believe. Well, it's because it's a Boolean, so we can't really say nil since we didn't declare it as an optional. We didn't get into that, so I'm not going to do that. But I'll say does not equal true. Okay. So, That's really all we're going to talk about on if-else statements. Go ahead, play around with them, try to get your code to do different things based on the condition of a variable. Before we move on, make sure you understand control flow if-else statements. Okay, so we're still talking about control flow, but we're going to switch gears a little bit, and we're going to talk about switch statements. So that brings up our tech info byte for switch statements. Switch statements perform basically the same function as an if-else statement, but perhaps in a more succinct and better format. Switch statements must be exhaustive or use a default clause, which I'll explain in a second. And switch statements are used with enumerations and error throwing functions to power Swift 2.0's new error handling quite nicely. So let's take a closer look at switch statements right now. So we're still talking about control flow. Switch statements is the topic. And switch statements are very similar to if-else statements in that they allow you to evaluate the value of a property and do different things based on that value. So to demonstrate this, I'm going to create a variable called name. I'm going to set that equal to the string of JSON. And then what we're going to do is we're going to switch on name. So in order to do that, we say switch. And then we say what we're going to switch on, in this case name, and we open a code block for our switch statement. And inside our switch statement we write cases. So the first case is going to be JSON. So in the case that the name is JSON, then what we're going to do is we're going to go ahead and print a line that says Jason is a programmer. Okay, and then we can add additional cases. So I'll say in the case that it is Christina, then we do our colon, and we're going to do a print line on this case as well, and we'll say Christina is a kitchen designer. And then we can add as many cases as we like, so I'll just add one more. And we'll say case Lenny. And in the case that it's Lenny, we're going to print a different string. And we're going to say Lenny still needs a good job. And then you'll see that we're still getting an error. And that's because we haven't covered all possibilities for the variable name. And covering all possibilities for the variable name would be almost impossible. So what we do is we add what's called a default case using the default keyword. And in there, all we're going to do is break. And break just means to go ahead and get out of the switch statement. So now, you'll see if I switch this to Lenny, then that's a valid option, and it says Lenny still needs a good job. Okay? Now if we switch it to someone else's name, like if I said Leo, then that wouldn't evaluate. It would just break out of the switch statement, and it wouldn't do anything for us. Now it is interesting to note the way that this formats, because really it should look like this, and sometimes Xcode does this perfectly, and other times Xcode doesn't, and that's just for readability's sake. Okay? So at this point, you know the basic workings of a switch statement. So I want to give you another example. So we're going to create a variable called score, and we're going to set that equal to 88. So this will be like a test score or something. And we're going to switch on that score and open our code block for our switch statement. And in here, we can make a case for a range. So if the range is 0, and then our range operator is ... through 59, then we can say print line here, and we can say you scored an F. Okay. Then we can make another case statement for 60 through 69. And in that case, we would print you scored a D. So I just wanted to show you how you can do ranges here. So in the case for 70 to 79, then we would print you scored a C. And so on. I'm not going to go through all of them, so we're not going to get to have a B or an A. But in the case that it's 100 exactly, we will do a different print line. And we'll say you had a perfect score. And then we'll put a default case in here to catch anything that slips through, like the A's and B's. So we'll do a print line on this, and we'll just say you scored well. Okay, so now that we have our default, we don't have an error any longer, and that's just showing you that you can do the range operator. Now there is another range operator, and that is the ... less than operator. So if I use ... less than 59, then that will give me a range from 0 to 58 because I'm not including 59 with this type of range operator. So I'm going to switch that back so it still evaluates our scores correctly and we're not missing something for 59. So right now we're capturing values for 0 through 79. Anything from 80 to 99 is uncaught and will be caught in the default case, in addition to anything over 100 or a negative score, if that's possible. And in the case that it's 100, we're going to write out that you had a perfect score. So let's just verify that this is working. We'll make it 100. And it says you have a perfect score on the right-hand side. So you see that's working just as well. So really, I'm not going to spend too much time on switch statements because we are going to revisit them when we talk about error handling. So do yourself a favor, get familiar with switch statements, play around a little bit with them, and then we'll see you in the next video. So we're still talking about control flow. This time we're going to switch over to the ternary operator. And if you're not familiar with what the ternary operator is, don't worry, you'll be familiar in a second. It's time for our tech info bite on Swift's ternary operator. The ternary operator in Swift is a shorthand way to write an if-else statement that has only two options. The ternary operator is widely used, but it's recommended only when the condition to evaluate is simple and straightforward. And always keep in mind that you should always prefer readability over compact code. So your decision to use the ternary operator or not is completely up to you, but let's take a look at it. So as we mentioned, the ternary operator is a compact way to write an if-else statement that has either one or two options, or actually that has two options, period. So let's go ahead and we'll write out an if-else statement that we can work off of. So we create our variable for temp again, and we're going to set that to 28. And then we're going to create a variable for is freezing, and we're going to make that a Boolean, and I'm not going to give that a value at this point. But then what we're going to do is we're going to do an if statement that's going to set the value of is freezing based on the temperature. So we're going to say if the temp is less than or equal to 32, then what we're going to do is we're going to set is freezing to true, and otherwise we'll open a code block, we'll set is freezing equal to false. Okay, so now that's your basic if-else statement, but there's a way to write this in one line. So we can check in one line what the value is for freezing and what the value is for temperature, and set is freezing based on that. So if we just say is freezing and we set that equal to temp, if it's less than or equal to 32, then we're going to say true. Otherwise, we're going to say false. So if you see the syntax there, it's actually pretty easy to follow. This is saying we're going to set the variable for is freezing, and if the temperature is less than 32 or equal to 32, then, which we indicate with a question mark, we're going to set that value to true, and otherwise, which we set with a colon, we're going to set that value to false. Okay, so you see that's a nice compact way to do it, but are you going to know what that says a couple years down the road? In this case, probably you will, but in more complicated code examples, you may not. So it may be worth still doing the if-else statement rather than using the ternary operator. But I do want to show you one other thing with the ternary operator, which is pretty cool, is if we declare a variable. So we're going to declare a variable called statement, and we need to say that that's going to be a string, and we're going to set that equal to is freezing. If that equals true, then we're going to set it to it's freezing, because we said it was going to be a string, and otherwise we're just going to set it to not freezing. So you'll see that evaluate here in a second, and it says it is freezing because the temperature is 28. But notice if I change this to 33, then you'll say that everything changes to false and our statement reverts to not freezing. So that is kind of like a property observer, which we'll get into later, but that's kind of why that's a neat little line of code here. And you'll see that we can use one line instead of using 5 lines up here. Okay, so the ternary operator can be a valuable tool. It can save you some time. It can save you some space. Whether or not you're going to use it or not very much is really up to you. You may decide to adopt it, or you may decide to not use it at all. But just be aware you will see it from time to time in other people's code, so you should be aware of it either way. And that's going to be it on the ternary operator. We'll see you in the next video. So we're still talking about control flow, but we're going to switch to loops, and specifically the for and the for in loop. So it's time for your tech info bite on loops. For loops allow us to iterate over ranges or indexes quickly to perform repetitive tasks. The standard for loop allows you to set 3 attributes as you format it, and those are to create a variable, to evaluate and set its value, set the condition under which the loop will run, and increment or decrement the evaluation variable. And a for in loop allows us to iterate through collections like arrays and dictionaries. So let's take a closer look at loops. So for and for in loops, we'll start with the basic for loop. And if you're coming from another programming language, then you probably recognize this syntax a little bit. So the way it starts is we say for, and we create a variable, and I'm going to create this as I, and I'm going to set that equal to 1. And then we put a semicolon, and that sets the variable up and sets its initial value. And then we want to set the condition that we want this to run. So we're going to say whenever I is less than or equal to 10, we want this to run. And we put another semicolon. And then we want to increment I. So we say I plus plus, and that plus plus syntax is just basically the same as I plus 1. But since we're lazy programmers, we came up with a way to say plus 1 quicker, which is plus plus. Now, if you wanted to decrement it, you could say minus minus. But at the end of that syntax, we open up our for loop code. And in here, this is what's going to happen when the loop runs. So what we're going to do is we're going to go ahead and print a line that says the value of I is, and then we'll dynamically pull out the value of I. And you'll see on the right hand side that it says it's doing this 10 times. And if we look at it, you'll see it gives us the last value at least. So this is done 10 times, it says the value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but it's only showing us that the value of I is 10 because that's the last time it ran. But rest assured it's doing the other 9 times as well. Okay, and it's doing it very quickly. Alright, so let's move on, and we're going to take a look at a for in loop. So in order to utilize a for in loop, we need something like an array. So I'm going to create an array of names. So I'm going to say names equals, and you declare an array with square brackets, and inside you put your values separated by commas. So I'm just going to create a couple empty strings in here, and I'm going to fill these strings in with some dog names. So Mikey, Latte, Bianca, and Cassidy. And those are our names. Now what we want to do is loop through those names. So what we could say is for name, which is just something that we're making up, in names. Then what we want to do is go ahead and print our name. And you'll see that it does it 4 times, and if we look at it, it's just going to pull out one of those, the last one, which is Cassidy. So you see that it loops through and it prints out the name 4 times. And if we look at the console, you'll see that it does them all, and the same thing with the value. Okay, so let me close that console down, because there's one more example I want to show you, and that's how we loop through a dictionary. Okay, because we loop through a dictionary in a slightly different way, because the dictionary is formatted slightly different. So let's create a dictionary. So I'm going to create a variable called inventory, and I'm going to set that equal to a dictionary. So for the key of 1, and I'll explain dictionaries in more depth later, we're going to say that that's a television. And then for the key of 2, we're going to say that that is a computer. And for the key of 3, we're going to say that is a console. So now we have a basic dictionary set up. It's an integer string dictionary, as you can see. And what we're going to do is we're going to loop through this. So the way you loop through this is using what's called a tuple. So you say for, and then you put a tuple here. So for key and value in inventory, and we open our loop so that we can do whatever we'd like in here. And in here what we're going to do is we're going to go ahead and print, and what we're going to do is make it a string, but we're going to print the key and then the value. So we'll print the key, and then we'll print the value. And you'll see on the right hand side that that's done that 3 times. And let's see what that output looks like. So it says 1 television. And the reason we're not getting it to show the last one is because dictionaries don't return themselves in any particular order. So right here it's showing us the first one, but this is actually the one that's being returned at the very end. And you'll understand that a little bit more once we go over dictionaries. But those are for and for in loops, and that's basically how they work. So they are good for getting small tasks done relatively quickly, or extremely quickly actually. So keep in mind the way you could use these with arrays and dictionaries, and also ranges. Okay, and that's going to be it on for and for in loops. We'll see you in the next video. In this video we're going to continue talking about loops. We're going to move on to the while loop and the repeat while loop. So it's time for your tech info bite on loops. A repeat while loop allows us to iterate over ranges or collections, but because the way the code is formatted, it's guaranteed to run the code at least once, before it even evaluates the condition. So that is a repeat while loop. A standard while loop will run the code and evaluate the condition at the same time. And repeat while loops replace the do while loop syntax in Swift. So let's take a closer look at these loops. So understanding while loops and repeat while loops is actually pretty simple. The first thing for a loop to work, and the first thing we're going to work with is a while loop, is that it needs a variable to go off of. So we're going to create a variable called x and set that equal to 1 right here. And then the while loop basically says while x is less than or equal to a value, we'll say 10. Then in here, what we want to do is go ahead and print the value of x. And we also need to increment x as well. Otherwise, it's going to do it over and over and over and over because it's always going to remain 1. If we increment x, then it will do it 10 times, 1 through 10. And you'll see that it will just print out the value of x each time. And this is a graph of it, but this is, well, it's not showing me the x, but you see that it's just increasing 1 each time. Okay, so that's a basic while loop. So they're fairly simple. They just go off a variable, and they evaluate that variable, and if that variable is less than or equal to whatever you set it to, then you can do whatever code you want in here. But you need to make sure that you increment x. This way it eventually stops, otherwise you'll have a loop that keeps running. And the loop that keeps running will run until your memory on the device runs out, and then it will crash. And it'll do the same thing on your computer in the playground actually. It'll run until the memory runs out and then crash. Okay, so a repeat loop is very similar with one exception, and I'll show you. So I'm going to create a variable called y and set that equal to 1. And then what we're going to do is we're going to say repeat. Now this replaced the do while loop. It's now a repeat while loop. So we say repeat, and we immediately open up a code block. And in this code block, we do whatever we'd like to do. So in this case, we're just going to go ahead and print out that y is equal to, and we'll just pull out the value for y. And then what we need to do after this is say while, and then set a value or a condition to be met. So while y is less than or equal to 100. So now you'll see that we have a loop that's continually going, and that's because I didn't increment the loop, and that should be done right here where we do y plus plus. So if my playground can recover from that, then you'll see a working while loop. Okay, there we go. So it stops at 100 times, and it just prints out y is equal to whatever the value at the time during the loop is. So there's our graph. And can we get values? It says y is equal to 100, but it's off the screen for you. So basically it's doing what we want it to every time. Don't forget to put your incrementer there, and then your condition here. So if you notice, this is always going to print this at least one time, because it doesn't actually evaluate a condition until after it does that initial run through. So it says repeat, we do what's in here, and then we evaluate the condition. All right? And really, that's all that there is to say about while and repeat while loops. They're pretty straightforward, and they're actually very useful in your code.